Hello, you're welcome to this lesson. In this video, you are going to solve this question I have on the screen. The question says, if the end of the cable in the figure below is pulled downward with a speed of 10 meters per second, determine the speed at which block B moves. Indicate by an arrow the direction of block B. Okay, so let's look at how you are going to solve this question. So first of all, to solve this question, you have to study the figure very well and look at what is happening. So looking at the figure here, we have two ropes here. Okay, we have two cables here. This will be the first cable. Okay, and then I have another cable here, which will be this cable, the long one. You have one long one and then one short one. So this will be the second cable. So let's take note of that. So let's look at how you are going to solve this question. So to solve this question, first of all, you have to draw a datum. So let's go ahead and then do that. So I'll draw my datum here through the first two pulleys at the top. So this is our datum. Okay, so we're going to, this will be the reference line where you're going to determine the length of the ropes from. So let's look at what you are going to do. So I'll measure from the datum to the center of the pulleys. Okay, that's taking the length of the cable. So I have from the datum to this point here. Okay, this becomes SB. Okay, I'll name this as SB. Okay, and then I will draw another line here from the datum to where the cable ends. Okay, and then this becomes my SA. Okay, and then I will draw another line here to the center of this pulley. This becomes my SC. Okay, so that'll be the labeling for the figure. Okay, so you didn't have to do all this on the question. Okay, I think you will have to draw a free body diagram and then do the dimensioning and the labeling. I'll not advise you that you do it straightly on the question. Okay, so now let's look at what you are going to do. So you are going to write an expression for the length of the two cables. Okay, so let's look at that. So for the first cable, which I'll name L1, you're going to have this cable. Let me trace it. You're going to have this cable. Okay, and then we ignore the length behind the datum. Okay, we ignore that part of the rope. Okay, so for the first rope, the length will be SB plus SC. This should be equal to L1. Okay, and then let's do same for the second rope also. So let me trace the second rope so that we can see it clearly. So I have from here a little crooked. Okay, so I'll trace this all the way to the end. So this is the second rope. Okay, so let's write an expression for the length of that rope also. So we are going to have this length here. Let me indicate it. This length here. Okay, this length here. So to get that length, we will have to subtract SC from SA. Okay, because SC is the top part here. So when you subtract SC from SA, then you get the remaining length, which is this length that we have here. So let's look at that. So we are going to have we're going to have SA minus SC. Okay, this will give us this short length that we have here. Okay, and then from there you're going to have plus, then we need another length. Okay, so let's look at that one also. So that would be from the center of this pulley here, okay, to the center of this pulley. Okay, so we need this length. So we need this length here. So to get that length, you have to subtract SC from SB to get that length. Okay, so you are going to have plus SB minus SC. Okay, so when you subtract SC from SB, you're going to get this short length that we have here, and there's only one of that, so that's all. And then you're going to have plus. So for SB, we have one here, we have another here, and then we have another here. So that will be 3. So that will be plus 3 SB. This should be equal to L2. Okay, so we are going to solve the question using these two equations. So now let's simplify equation 2. So for equation 2, we are going to have SA, okay, I'm taking them out of the bracket, minus SC plus SB minus SC plus 3SB to be equal to L2. So when you simplify this, you're going to have SA minus 2SC plus 4SB. This should be equal to L2. Okay, so this is the equation that we have for the equation 2. Okay, that's the simplified form of equation 2. So now what you do is that you substitute equation 1 into equation 2 by making SC the subject. Okay, so from equation 1, we can have SC to be equal to L1 minus SB. Okay, so you then substitute this into this equation that we have here. So you're going to have SA minus 2 multiplying SC, which we now have to be L1 minus SB. Okay, plus 4SB to be equal to L2. So this is the equation we have now. So now let's simplify it by bringing the terms out of the bracket. So I'm going to have SA minus 2L1 plus 2SB plus 4SB to be equal to L2. So let's simplify this. So I'm going to have SA plus 6SB to be equal to L2 plus 2L1. Okay, so this is what you have now. Okay, so let's differentiate this so that you can get the equation for velocity to solve the question. So when you differentiate this, you're going to have VA plus 6VB to be equal to 0. So now we want to find the speed of block B. Okay, so for that reason, we are going to make VB the subject. So you're going to have 6VB to be equal to minus VA. Okay, so we will divide both sides by 6. Divide both sides by 6. So this will cancel out this. So you're going to have VB to be equal to minus VA over 6. Okay, so now what we will do is that we have to define the directions and their signs. Okay, so I'll consider the downward direction to be negative and then the upward direction to be positive. So for this reason, we're going to have the velocity of the cable when it is pulled down to be equal to, that's VA will be equal to minus 10 meters per seconds because you are considering the downward direction to be negative, and then the end of the cable was pulled downward. So the velocity at the point A will be negated. So let's substitute that into this equation. So I'm going to have VB to be equal to minus VA, which is minus 10 divided by 6. So I'm going to have VB to be equal to 10 divided by 6. Let's look at the value for that. So that gives us 1.67 meters per second, and that's positive. So that means that it will be moving up. So what that means is that when the end of the rope, okay, when this end of the rope is put downward, the block B will move upward. So that's what this means. Thank you very much for watching this video. Please make sure you like the video and subscribe to the channel.